For years, it was called the most ambitious and controversial fighter jet program in history. Billions of dollars in development, countless debates, and endless promises of air superiority. But now, a new question arises. Has the F-35 Lightning II finally entered full-scale production? Today, we're going inside the world's most advanced fighter jet program to uncover what's really happening behind the doors of Lockheed Martin's massive production line, and what this means for the future of global air power. The F-35 Lightning II, developed by Lockheed Martin, represents the fifth generation of multi-role stealth fighters, designed to replace aging platforms like the F-16, the A-10, and the AV-8B Harrier. With its revolutionary sensor fusion, stealth profile, and unmatched network capabilities, the F-35 is not just a jet, it's a flying data center that links every asset on the battlefield. The program began in the early 2000s under the Joint Strike Fighter Initiative, uniting the U.S. Air Force, Navy, and Marine Corps under a single design with three variants: the F-35A, conventional takeoff and landing, the F-35B, short takeoff and vertical landing, and the F-35C, carrier-based for naval operations. Over 2 decades, the F-35 evolved from a costly experiment into one of the most demanded combat aircraft in modern history. Production began modestly with low-rate initial production, building small batches for testing and training. Each lot brought new refinements, improved software, upgraded avionics, and enhanced manufacturing precision. But by 2024, Lockheed Martin officially transitioned the program into full-rate production, the phase commonly described as mass production. The company's Fort Worth, Texas facility, stretching over 1 mile long, now produces between 14 and 16 aircraft per month, targeting 170 to 190 units per year. Additional assembly lines operate in Cameri, Italy, and Nagoya, Japan, supporting Allied orders. Every F-35 is built using digital twin technology, a virtual model that tracks every component in real time. Robotic arms, laser alignment, and augmented reality inspection ensure tolerances measured in microns. This is not just manufacturing, it's aerospace precision at a national security scale.
Today, more than 17 nations operate or have ordered the F-35, making it the backbone of Western air power. Countries like Finland, Poland, South Korea, Australia, the United Kingdom, and Japan are expanding their fleets, integrating the jet into a common digital ecosystem. Each aircraft shares data instantly across secure networks, creating a unified situational picture that no previous generation could achieve. In practical terms, an F-35 flying over Europe can relay targeting data to ships in the Mediterranean or to missile batteries in the Pacific, all in seconds. This level of interoperability makes the F-35 not just a weapon, but a system of systems, central to NATO's deterrence strategy and to the United States' vision of network-centric warfare. Yet, mass production doesn't come without challenges. The ongoing Block 4 upgrade, a major enhancement to sensors, electronic warfare, and weapon capacity, has faced delays. The F-135 engine, built by Pratt & Whitney, is also being upgraded to handle the increased power and cooling demands of next-generation avionics. Despite these issues, the production rate continues to climb, and by the end of 2025, more than 1,200 F-35s have rolled off the line, a milestone unmatched by any fifth-generation fighter.
So, has the F-35 Lightning II entered full-scale production? The answer is yes, and beyond that, it has entered a new era of industrial momentum. With hundreds produced each year and thousands planned in the coming decades, the F-35 isn't just shaping air combat, it's redefining how nations build and fight together. The world's skies are changing, and the F-35 is leading that transformation. If you found this analysis insightful, don't forget to subscribe, give this video a like, and turn on notifications for more deep dives into military technology and defense innovation. Because the future of warfare begins with understanding the machines that define it.